Hello, this is Jeon Parjong. Today we will study Introduction to Data Structures. Today's chapter is Chapter 7, Programming with Recursion. This figure shows recursion, right? So the DARs. So the big DAR box, small one, and smaller one, smaller one. So this is the recursion. So the typical recursion function is a factorial. So what is 3 factorial and this next person? Okay, 3 factorial means 3 times 2 factorial. Okay, so kind of recursion, right? So 4 factorial, 3 factorial, 2 factorial. Okay, so 2 factorial is 2 times 1 factorial. By the way, what are you doing tonight? So 4 factorial, 3 factorial, 2 factorial, 1 factorial, and another last person is 0 factorial. 0 factorial is well-known value 1, and then this guy tell her 0 factorial 1, right? So 1 times 0 factorial is 1, and she tell him, okay, so what is 2 factorial? He tells her 3 factorial value, and the 4 case, the 3 factorial value times 4, she can know 4 factorial. Okay, so this is kind of recursion. So she called 3 factorial, 2 factorial, 1 factorial, 0 factorial, and then reversely report the factorial value. Each one can calculate the factorial value. So what is recursion? Recursive call is a method call in which the method being uncalled is the same as the one making the call. Direct recursion and indirect recursion. Direct recursion is recursion in which a method directly calls itself. On the other hand, indirect recursion is recursion in which a chain of 2 or more method calls returns to the method that originated the chain. So recursion, you must be careful when using recursion. Recursive solutions can be less efficient than iterative solution because of a function call. Okay, we will see related function call having activation record. Still, many problems lend themselves to simple, elegant, recursive solutions. Some definitions for recursion: base case, general recursive case, okay, and the recursive algorithm. So recursion case, 2 cases. Base case is the case for which the solution can be stated non-recursively because the value is known. On the other hand, the general or recursive case, the case for which the solution is expressed in terms of a smaller version of the recursion function. Finally, a recursive algorithm is a solution that is expressed in terms of a smaller instances of itself and a base case. So recursive function call. This is a function call in which the call of function is the same as the one making the call. So function name is the call, but the parameter is reduced. Okay. In other words, recursion occurs when a function calls itself. You must avoid making an infinite sequence of function calls. This is called infinite recursion. So finding a recursive solution, each successive recursive call should bring you closer to a situation in which the answer is known. It is called a base case, right? So a case for which the answer is known and can be expressed without recursion, it is called a base case. On the other hand, each recursive algorithm must have at least one base case as well as the general, that is the recursive case. This shows general format for many recursive functions. Okay, so the if and else, some condition is given, so the answer is known. The base case solution statement is handled. Otherwise, recursive function call is handled as a general case. Writing a recursive function to find n factorial. Okay, so we can call the function factorial 4 times, 3 times, 2 times 1. Okay, so for situation in which the answer is known, 0 factorial case is 1. So our base case could be along the lines of number equal to 0. This is 0 factorial, just return 1 because 0 factorial is 1. And then find n factorial, right? So factorial n. So you can write this n times n minus 1 times this one. Recursively, we can write n factorial is n times factorial n minus 1. Okay, so this function are called recursively. So this is a recursive solution, factorial function. Parameter is integer number. Okay, so the number less than 0. So we have base case, this condition, and else is a general case for recursive case. So number is 0 is 0 factorial, right? Return 1. Otherwise, return number, okay, factorial, right? So this one is times, okay? So pen, so here this is lesser than, okay, lesser than plus times. Okay, so number times factorial number minus 1. Okay, so this is factorial definition. So 3 question method of verifying recursive functions. Okay, the base case question: is there a non-recursive way out of the function? Secondly, smaller caller question: does each recursive function call involve a smaller case of the original problem leading to the base case? The general case question: assuming each recursive call works correctly, does the whole function work correctly? So we have another example is exponent, okay, exponential number. So 2 raised to the power 0 is 1, 2 raised to the power 5, or we can get call 2 power 5 is 2 times 2 power 4. So recursively we can define like this. Okay, so xn is x times x power n minus 1. Okay, so we can recursively, okay, x power n recursively define with the x power n minus 1, like this formula. So the power case, the x is base, n is exponent. Okay, so the exponent is a 0 case. Okay, any number power 0 is 1, base case. Otherwise, x times power x, the parameter n minus 1. Okay, and now we can define list, because the recursive function case, if linked list given and print out linked list value recursively, so we define struct list type int length, the number of elements in the list, and then info. here. So this case we using the array, okay, rather than actual linked list, and list type list. And then recursive function to determine if value is in the list, okay. So we can check one step at a time. So the value in list case, list array, and the value we can check start index, okay. So at the beginning list 0 is the start index, and then we can check if value is not here, and then we can move start index to the right, okay. So this case start index array element is 95 value, index of current element to exam, okay. So right hand side this is needs to be searched, okay. The length -1 is the end of element in the list array. So the value in the list case, the list array, the value to be searched, and the start index, okay. So we can check the list info start index is equal to value or not. If equal, this is okay, base case true. Otherwise okay, start index is the end. So if this one is list length -1 case, if is not true, and then else if is executed, right. So we are already checked the last element, okay, in the list, right. So in that case first, because the value is not okay existing list. Otherwise we can recursively call a value in list, okay. We make start index, okay, +1, okay. We can searching arrays to the right, okay. The why use recursion, those examples could have been written without recursion, like iteration. Instead, the iterative solution uses a loop, like a for loop or while loop, and the recursive solution uses an if statement. However, for certain problems, the recursive solution is the most natural solution. This often occurs when pointer variables are used, like linked list case. So now we list type, okay, so is linked list. So node type is again node info, this is integer, and next pointer, and the sorted type list case, and the list data is point the first linked list node. So list data, so we have this kind of linked list, okay. So we want to print out the value, okay. So using recursive function, recursive print leave print this one, okay. So we can the basic idea, we can go to, if next point exists, we can go next point exists, next, and then this one is not next null, right. So this guy print return and print return print return print return a return, okay. So and then recursively we can like a backward print the list value. So the base case and the general case, base case may be a solution in terms of a smaller list, okay. So the list size 0, okay. There is no more processing to do. General case brings us closer to the base solution, right, because the list is shrink, something like that, right, toward the base case, okay. So that is the number of list element to be processed decreases by 1 with each recursive call, and by printing one element in a general case and also processing the smaller remaining list, we will eventually reach situation there well 0 list elements are left to be processed. And then in the general case, we'll print the elements of the smaller remaining list in reverse order, and then print the currently pointed element. Okay, so let's look at reverse print, leave print here. Okay, so list ptr null means not null case, still we have print out something. So leave print list ptr last. Okay, and we can process the last remaining list, and then we can print out currently searched element. Okay, so list info. Okay, like this using cout. So according to this one, if a base case return, okay, so actually this return, and okay, so the last element print, and then this is okay, return, and then this also called, right, finish the function call and then return. So according to this, we can print backward from the end of list node toward the backward, okay, reversely toward the first node info. So function binary search. So we learned the binary search algorithm. Now we try to use in recursive function rather than iterative function. Okay, so the binary search takes a sorted array info and two subscripts from lock and to lock, so from location and to location, and item as argument. It returns first if item is not found in the element info from lock to toward. Okay, this range. So from is start index and to log is end index. Otherwise, it returns true. So binary search can be written using either iteration and or recursion version. So binary search info array, and this is item to be searched 25, and the 0 is from location, 14 is to the end of location, right? So index is 0, 14, right? So we can check the middle value. So middle value and this one is greater, right? So we can check the second half rather than first half. And the middle point value 22, right? Still 25 larger, right? So we can check second value, second half. And also we can middle value 25, now the first half. And then first half, the value is 24 only, right? So there is no 25. So we return false. So we using template class, the item type. So item type is an integer, okay? So binary search, the info array, one-dimensional array. We can using the square bracket for array parameter, and the item to be searched, and from lock to lock. The info array is starting index, info array is end index. Okay, so we middle point calculate, right? So from log is greater than to log is already we searched info array. So in that case, base case not found, just return false. And because we searched the info array, okay, the fully, so there is no element, okay, for item. And the else case, this is a general case. We can calculate middle point, okay, index from log plus the 2 log divided by 2. This is middle point index, and then compare info middle point element and the item. Equal case true. So this is first the base case. This is actually the second case. First case is not found. This is a found case. Otherwise, we can check item is less than the middle point, the value in info array. So we can search lower half, first half. Otherwise, we can search the upper half, second half. Okay. So in that case, middle point -1 is end index, middle point plus 1 is start index. So when a function is called, a transfer of control occurs from the calling block to the code of the function. So basically, if we function call, we need to register the returning an address in the memory. Okay, so it is necessary that there is a return to the correct place in the calling block after the function code is executed. This correct place is called the return address. So we can implement this one, runtime case using activation record. Okay, so activation record frame, this scores the return address for the function call, and also the parameters, local variables, and the function's return value are stored in stack activation frame or activation record. The activation record for a particular function call is popped up the runtime stack when the final closing brace in the function code is reached, or when a return statement is reached in the function code. At this time, the function's return value, if a non-voided return type case, is brought back to the calling block return address for use there. Okay, let's take a look example called the function. So parameter is a and b integer type, and then the result. Okay, so result local value variable. Okay, to return the result value. B is equal to 0 base case. In that case, result is 0. Otherwise, else if B is a positive integer case, first general case, we have recursive formula A plus the first parameter plus function A B minus 1. Okay, we reduce by 1 B value. This is instruction 50. Okay, so we can assuming this is instruction 5 if this C language is translated into machine code. And else this one is second general case. Okay, B is negative case. Okay, 0 positive and negative case. Parameter A and B is the symbol. Okay, this one is minus. Okay, so this location is instruction 7 in machine code. Okay, and then result return. Okay, here. So we take a look runtime stack activation record. Okay, so this is client code X. Okay, assigned the value function call func 5 and 2. 5 is parameter A, 2 is parameter B, right? So original function call this location in machine code is instruction is 100. Okay, so if we call here the return address, this is a return position, right? Is 100 return address, and then 5A, 2 is B, right? So and the result is an unknown, and then function value return value is not unknown. So original function call, okay, for func 5 and 2, and then so we can recursively call, right? So in that case, here function value is not, and the result is not known, right? So and then we can call this value reduced by 1, right? So this is B is becomes this, the A is 5 here, and then we can call again return case 50 because this recursive location is 50, right? This first general case, so this is return place. So instruction location is 50, so that's why the 50, and then we can call again. Now return a value also to 50, the same the base case. This is a general case, right? And then the B becomes 0, right? So this is base case, right? B becomes, and then now we can calculate the result function return value and then return the 50. And then we can calculate the result and then return value also none. Okay, also return here. Now, yeah, this one is 100, right? This one. Okay, so we calculate all value and return this colors location in structure 100. Show activation records for these cores. So the first one, the punc -5 -3, and B case. The second one is 5. This is -3. So B case, if negative case, we have 2 second the general case, right? So what operation does the punc AB simulate? Okay, so we can see based on the code before. Now tail recursion. So tail recursion case, recursive function is always rightmost tail. The case in which a function contains only a single recursive call, and it is the last statement to be executed in the function. Therefore, tail recursion can be replaced by iteration to remove recursion from the solution, as in the next example. So basically, we can transform recursion version to iterative version. So the value in list is we can implement right using iterative some loop, but here the tail recursion case, similarly we can solve previous, right? So the base case, first one, we check the start index value, and this one is the same or not. The same case we can check it. And the second case, the last element case. Okay, so here last length -1 case checked, right? If not equal case, this else statement, right? The last case already we checked the inequality, so we return false. Otherwise, this is a general case. We increase start index by 1 like this. Okay. So iterative version case, we can previous one is a recursion version. This is iterative version. So found this is a kind of a label. The first value is initialized, and then the value. This is found false, not is true, right? So this is false. Found is false, and then start index is less than index length case. So from 0 length -1, we can perform this value. Okay, so we can check the start index value and value equality, right? So if the equal case, the found set to true. Okay, and then this one is not found case false, right? And the exit and the return. Otherwise, we can increase index, start index 1 by 1, and then we can check from first index element to the last index element in list array. So use a recursive solution when the depth of recursive curves is recursively shallow compared to the size of the problem. Okay, so in that case, even though you can see recursive function requires activation record, right? This is the overhead for operating system, but the shallow depth is shallow. I think the recursive function version is fine. The recursive version does about the same amount of work as the non-recursive version, like iterative version, but some problem solution case recursion is much easier conceptually. That's why we are using like the quick sort case. Okay, the recursive solution is good for quick sort. The recursive version is shorter and simpler than the non-recursive solution like iterative version. Okay, so okay, conclusion is shallow depth, efficiency, clarity. Recursive solution is good. Okay, so thank you for your attention. If you have a question, please let me know. Thank you.